In this example, we're talking about money. We're talking about investing $1,000 at the beginning of each year. This is going to make it more difficult than other problems we've looked at. For 10 years. That means at the beginning of every single year, you put $1,000 into this investment plan. The rate of interest is fixed at 7.5 per annum. That means per year. And the money is compounded annually. Our job is to calculate to the nearest dollar how much the first 1,000 is worth at the end of the 10 years. So what happens in part A is pretty straightforward. You take $1,000, you put it at the beginning of the first year in the bank. At the end of the first year, it would have earned 7.5% interest. So that's 1 plus 7.5 over 100. Okay. But you want to know how much it's worth at the end of 10 years, not at the end of 1 year. And since we're compounding, that indicates to us that we have exponential growth or a geometric sequence. Therefore, 1,000 times 1.075 to the power of 10 will give us how much that first $1,000 is worth. So 1,000 times 1.075 to the power of 10. So therefore, that first amount of money is worth $2,061. We round to the nearest dollar. Part B is quite a bit more difficult. You're going to take this 1,000 and you are going to think about what it's worth at the end of 10 years. But each year, you're going to invest another 1,000. So the next year comes along, you put another 1,000 in, but you want to know what it's worth at the end of 10 years. So this next 1,000 only has 9 years to grow. Pattern continues. 1,000, 1.075 to the power of 8. The next year there only has 8 years till the end of 10, and so on and so forth. So to save time, I put this all in already, and I factored out the 1,000 and left these terms here as a sequence being added, right? And if you put that all in at once, you get $15,208 at the end of 10 years. Now, that's a long way to input it in your calculator. If you're slick and you factor the 1,000 out, there's an easier way thinking about these numbers in geometric sequence, geometric progression. And then if you consider that sequence that's left after you factored out the 1,000, you can use your formula booklet to sum up those terms, multiply them by 1,000, and you'll get the same result. Whichever method you prefer, doesn't matter. They will both give you the right answer. One takes more typing in the calculator. You can't see it, but all over here, I had to put in all these terms till I ended. And the other way, you have a shorter calculation, but it requires more thought to figure out that these terms here are also in geometric sequence or geometric progression.